Welcome to the NVIDIA Omniverse live stream, everybody. This is a very special one for a few reasons. One, I'm actually at NVIDIA headquarters today. I've actually had a great dinner last night with Ordinary Alan from our community. If you're watching, hey Alan, had a great time. We have a very special guest here from both NVIDIA and a very super special guest from Microsoft. We're going to be diving into building operational digital twins using IoT data, leveraging OpenUSD. We'll get into that in just a few minutes. They're waiting in the wings. First, a couple of quick announcements. We have our OpenUSD training labs are available on demand. These are the labs from GTC that people who attended physically got to experience, and those are now available without being gated. So feel free to go in there. Amelia, my producer, is sitting right next to me today, actually. She's waving. Is going to be posting that link in the chat in just a second. Along with that, we also have the other sessions from GTC, also now available via NVIDIA On Demand. This is a great opportunity to catch the content that you may have missed, or maybe if you were at GTC or attending virtually and got to see some of it, maybe you missed some because of overlapping sessions. But now they're all available. There's really no reason not to get the full information that's free to everybody now. We also have a great article. We'll post a link for this as well, with focus on Siemens, and they're leveraging OpenUSD with Team Center X. Ian Fisher was on a live stream recently talking about this. It's a fantastic story, very inspirational for those businesses who want to unlock the power of OpenUSD and maximize interoperability. Um, and then last but not least, really excited for these closing days of the OpenUSD Challenge. This is our latest community challenge in conjunction with the NVIDIA Studio team. We would love to see your OpenUSD projects, whether you're just starting out with OpenUSD or whether you're a veteran and have been working with OpenUSD for a while. Feel free to share your project, no matter what stage it's in, and put it up using the hashtag OpenUSD challenge on your social media of choice, and let others really learn and be inspired and motivated by the work you're doing. I think that's just amazing when people can really learn from each other. Speaking of learning from each other, let me bring up our guests. Here we go. Is Alex, and we've
Hey,
got Richard. And of course, we've got Ganesh. Gentlemen, thank you so much for joining me today.
Thank you.
Really big honor. We're going to be diving into a fantastic topic, a very timely topic: operational digital twins using IoT data and OpenUSD. We really have not discussed IoT data too much on these live streams, but it's a very steady topic in the community. So everyone who's watching, you're in for a big treat. Feel free to ask your questions, and we're going to be watching the chat throughout the live stream. Um, uh, if at some point you want to engage further after the topic, you can head to our Omniverse Discord server, which is discord.gg/NVIDIA Just post in the live streams channel and tag me if you like, and then I'll chase down one of our guests for an answer on a follow-up question. But before we get started, let's do a quick introduction to our great panelists here. So starting with Alex. Alex, thank you so much. You're from Microsoft, obviously. You have a great background. Can you tell everyone a little bit about yourself?
yeah, so my background is software engineering, so I've not got a background in hardware per se, but I've spent probably the past 15 years in the energy, in the energy and manufacturing sectors, strong focus on leveraging IoT data and AI, taking that data, developing digital twins on and off with
Amazing.
that data, and then applying the expertise to uh, you know, from just contextualizing the data and contextualizing it and ingesting it into the cloud and just visualizing and doing analytics, all the way down to taking that analytics, training ML models, and then doing stuff like closed loop controls with that ML models.
Very cool. And as opposed to, we'll explore today, there's actually a few different pieces all connected with what we're going to be showing off. So we're going to dive into all of that, including people are very interested in what's going on behind Alex right now. Stay tuned. You will see more of that in just a few minutes. It's better and better every time I see him. Thank you, Alex. And Ganesh, thank you so much for not only joining me today, but all your help in preparing for this live stream. It's going to be chock full of great information. You want to give everybody a little bit of background on yourself?
Yeah, absolutely. Thank you, Edmar. So my name is Ganesh Shivraman. I lead the Omniverse partnership, and Microsoft is a strategic partner that I am driving and leading. We've been talking about digital twins and building operational digital twins and connecting the physical world with the digital world for a while. What we are going to see in the next 50, 55 minutes in this session is actually how do you do it? What's the value? Why should we care? So those are the kinds of questions that we'll dive deeper into it. And it's incredible that we have Richard and Alex. Richard has been in our Omniverse engineering team instrumental in building some of the foundational samples and examples to help Microsoft and Alex and the rest of the team to leverage their Azure tech stack, Azure IoT and others to kind of create that connectivity tissues between the physical and the digital world. So that's what we are here for, and we're really excited.
Amazing. Yeah, it's going to be a fun-packed hour for sure. Okay, last but not least, we have Richard, who's going to be diving into some of the tech we just mentioned a minute ago. Richard, thank you for joining us.
Thank you.
Great pleasure to have you on the live stream. You want to also give everyone a little background?
Yeah, well, I'm actually tied to the hip with Ganesh with respect to this whole IoT initiative and getting out into the public space. I work on the engineering side with respect to digital twins. Been with NVIDIA now for about 2.5 years, and before that, I was creating digital twins of residential energy consumption for being able to model the residents and basically how energy is being consumed and generated in the home. And I'm just having a fun time bringing all this to life. So that's what I enjoy doing.
That's awesome. You were probably fooling around with digital twins before digital twins was such a common term.
Yes, pretty much, yes.
Okay, well, actually, let's talk about that really quick for a second, just to put things in perspective about who could best define digital twins for kind of what we're diving into today. So we could give everyone a frame of reference because I think different people have different ideas of what digital twin can be or is, and it could vary based on the use and the application, right? So who would like to take that one? Just a quick definition of digital twins for this purpose.
Go for it, Richard.
Okay. Well, it's got varied representations, right? There's a visual element, which is the key. The key to what we're doing here is being able to visualize your digital twin in Omniverse, and then you've got the physical elements and you've got the analytical elements. So basically, everybody's got a kind of different perspective as to what their digital twin is going to be. Based on their use case. So my experience has been is either you're going down the simulation route or you're going down the analytical and the situational awareness route with your digital twins. And the idea here is that you can use Omniverse kind of to bring both of those worlds together and have coherent solution that you can provide to whoever needs whatever representation they might want. Yeah.
Perfect. And okay, so let's dive into the operational digital twins. I think Ganesh has a few things he could share with us on it as a kind of introductory overview before we get a deeper dive into things with Alex and Richard.
That'd be awesome. Richard, do you want to do a quick screen share? We can use the slides as a cue, and then we can go through that. Yeah. So if you go to the next slide, please. So I think that was a great kind of question setting, Edma, that you asked, what is a digital twin or what are the different types of digital twin? And Richard is right. There is no one kind. There are different types of digital twins that one can build. And the reason why the broader heavy industry is really excited about this is the massive $50 trillion opportunity to build these digital twins primarily to improve operational efficiencies, reduce cost, and speed up your time to market. So imagine any future factory that's going to get built. It'll not be actually built in the physical space first. It'll actually be built in this digital twin environment, in this virtual world environment. But when we're talking about building this in those virtual environments, you have to be not similar, but you need to be exactly the same as what you and I or anybody would interact in the physical space. That means gravity, physics, materials, all of those aspects matter when you're actually building these digital twins. And that's what is really exciting for us at NVIDIA, leveraging our accelerated GPU, because underlying that's the powerhouse that's powering all of these digital twins and the simulations that's required for it. And what Microsoft is bringing is its powerhouse of having all of this at massive scale, providing that infrastructure, providing that data layer, the tech stack that they have been actually having to run industrial automations and industrial systems for decades. So it's actually the the power of the two worlds of what Microsoft and NVIDIA can bring to bear to go after this incredible $50 trillion opportunity. So that's what is truly exciting, and that's why we are here, and that's the foundational piece. So if you go to the next slide, please, Richard. So with digital twins, it's not a fairy tale. It's actually happening as we speak. They're happening in different stages. It's basically helping different industries in different phases of their digital twin journey. So you could be building, as Richard was alluding to earlier, you could be building a design digital twin. You could be creating a simulation digital twin, and you could be talking about an operational digital twin. But for all of these, you have to have a 3D representation of the space that you want to build the digital twin against, and you need to have that as a baseline. And once you have that, then you can actually unlock several different use cases and improvements that you can actually get by using the digital footprint as your baseline, as your experimentation ground to run all of the efficiency improvements, getting more of the value. So the greatest example is if I take a factory line, a production line, if I'm getting 10 widgets out of that production line, and if I can get 12 widgets out of that production line without actually increasing any additional CapEx cost, how can I do it? And this is kind of a simple example, but that's the holy grail, especially with all the supply chain constraints, lack of skills and talents and labor force, geopolitical situations that's happening. These are actual real world problems that we all are facing on a day-to-day basis. So how can you get more out of the same investments and infrastructure? So that's where the digital twin and all the things that we are discussing here makes a lot of sense. So now the question is, okay, now if I have the digital twin, where does IoT and where does the operational digital twin make sense? So if you go to the next slide, Richard, the factories or the brownfield implementations. Okay, actually, let me cover this and then we can go to the next slide. So to enable all of this digital twin, there are some key technology enablers that we're using, and open standards like USD, Universal Scene Descriptors, which is kind of the underlying data format for everything that we do in Omniverse, is a critical piece to enable that. Regardless of what applications or tools that you're using, everything is actually interoperable through the USD data format. So open standards and using USD is a critical piece for it. And as I was saying, since the world of the future factories are all going to be actually be built in the digital world, they actually automatically become an incredible asset to train robotics and use generative AI as a mechanism to get that operational efficiencies and reductions of cost. So you can actually be starting to train and teach the things, from a process perspective, from an asset perspective in this digital world, using all of the new robotics and the generative AI technologies. And all of this is, of course, truly possible because of NVIDIA's accelerated computing and RTX capabilities as the underlying powerhouse that makes all of this possible. So if you go to the next slide, so I think that's the video that Alex is having as his background in this stream. This is an actual. This is not a video. This is a video, but this is a video shot of an actual operational digital twin, which is what Richard and Alex are going to get into the details in the next 45 minutes as to how this was actually accomplished. And what we're showing here is an actual robotic arm hooked up to Azure IoT, bringing OPC UA data, which is an industrial standard for all industrial automation data, over MQTT into Omniverse. And then how are we actually creating that as a USD layer that's driving that animation in Omniverse? So there's a lot of different pieces of technologies that has gone into this, but this is kind of the underlying and the foundation piece for this session. And we're going to talk about how to do this and get into the code, get into the samples, and walk through the entire process. So with that, I'm going to hand it over to Richard, and you can kick it off, Richard, with the Omniverse side of things before Alex can cover the Azure side of things.
That was awesome. Yep. Let me ask you one thing before Richard kicks things off. We had a couple questions in the chat. One was a difference between design simulation and operational twin. I'm sorry, what is the difference between a design, a simulation, I'll put this on the screen, a simulation and an operational twin? This is coming from Zia.
Okay, I can take that.
Okay.
So a design simulation to a twin, designed digital twin is essentially a twin that you would actually typically design a factory, design a car, design a warehouse, design an asset or a process. So you're basically designing all of that to create a photorealistic experience that's exactly the same as what the physical world would represent. Then once you have that design, then you can actually apply the simulation practice, the simulation algorithms, all the things related to actually make certain thing move and behave exactly as it's supposed to do in the physical world. So think about training or programming a robotic process or a process line with a discrete event simulation. So you want to actually simulate all of that, but for that you need to actually have a design digital twin as a baseline. And then think about an operational digital twin where you now have designed it, you have created a simulation, and now you're pushing all of that simulation code, the intelligence, back into the physical robot. And now the physical robot is actually operating in the real world. Now you want to bring that back, that operational aspect of it from the physical back into the digital world. That's the operational digital twin. So they all kind of feed into each other. It's not necessary that you need to have all of them to create a business case or a business value. You can start with a design and be satisfied. And we have customers and use cases where people are more than happy starting off in the design digital twin. And in most cases, they start in the design digital twin phase and then upgrade into the simulation and then upgrade into the operational. So that's kind of the way to think about those three.
And we already got a confirmation that was a great explanation. I agree. Real-time feedback. That's great, Ganesh. Thank you so much. And yeah, so we're going to look at some use cases now, I guess, with Richard and Alex. And if we didn't note it earlier, Alex is from Microsoft, so great honor to have him here with us today. And Richard and Ganesh are both from NVIDIA. So yeah, so are you going to be sharing your screen?
Yeah, he's sharing it, Richard. Yeah.
Gotcha.
Okay. So the initiative here was to make it easy to actually bring different use cases into Omniverse and create a kind of like a coherent ecosystem whereby you can actually just bring the data in, manipulate the data the way you need to manipulate the data, and then have these visual representations of what you want. We recognize that basically there's a number of various skill sets associated with each one of these. So the person that's developing the web page is not necessarily the same person that has a skill set for being able to do the 3D USD, as well as he's not necessarily the same person that's doing the IoT ingest data. So the idea was to create a sort of like this whole ecosystem where you can bring in the various skills that you need to build your solution up, and then build out a full, use case from beginning to end. So like this is kind of the whole picture of the puzzle, but the way we decompose it is pretty straightforward. Is we start with, you've got your IoT data, you've got your edge, and you've got an ingest service. You might be using Azure IoT, you might be using whatever platform you might want to. If you're in the energy space, you're using SCADAs, and you've got various platforms that are ingesting all that kind of data. So what we do is we say we don't actually play in that space. It's basically that's your space, you own it, you manage it, and you've got the skills associated with that. And you bring your data into those systems, and then basically you land it. So it could be structured, semi-structured data, whatever you feel you need in order to get that data there. And then once it's been ingested into your systems, this is kind of where we start playing. As this is kind of, we decouple this into what we call a headless connector. So your headless connector has the ability to connect into your ingestion sources. So if you're using Azure IoT, it could be OPC UA, it could be MQTT, it could be Service Bus, and just queues, whatever you want to be using on your internal systems. You could be bringing in that IoT data and ingesting it into the headless connector. At the same time, you could be incorporating in your enterprise data. Now, it's not only necessarily just enterprise data, because this is, as Ganesh mentioned earlier, is when you start getting into the simulation, you might be doing process simulation, right? So you might be taking some of this IoT data and combining it with process simulation and process simulation services in order to kind of like shape this data the way you need to do it as it's flowing through. And this headless connector will basically then just be a stateful environment that's durable, independent of the presentation. So as Microsoft, Alex is going to show, and the Microsoft solution is basically this headless connector is kind of running anywhere. It can run in the cloud, it can run locally. You can have multiple headless connectors running, and it's kind of running off and doing its own thing, and then it's sending out its results into a durable storage in Omniverse, and then basically it'll be available to be picked up by the environment that you're using for the presentation. So there's different ways of doing this. Is you can be pumping in, just IoT data or business data directly into the storage environment, and they can bring it into this kit application. This kit application will basically have a stage, which is what you're working with, and you'll have extensions or action graph that'll be responding to the data that's being brought into the environment. So it'll allow you to basically shape the data you want to do it. So the example in Alex's example is basically it's taking the information, the IoT information with the robot arm, and it's articulating the arm based on that. And it can be as complex as you need it. So you can have as many robots as you want running in the space, and then you can do what you need from it. And the other nice thing about it when we talk about the simulations is that when you get into physical simulations is that you can actually loop this data back to your headless connector. So you have the ability to basically write back into your environment, send it back to that nucleus storage, and have that headless connector that was pumping the data in actually receiving and responding to events coming from the simulated environment or the staged environment. So it provides with that, a nice ecosystem that's completely decoupled one from the other. Again, the skill sets are very different because the headless connector itself is running in Python. When you start getting into the kit environment, it's kind of like a Python environment, but you've got to have some knowledge of USD, which you don't necessarily need in the headless connector. The headless connector could be just data. So you guys are grouping data and creating data windows or whatever you need from that perspective in order to be able to pump it in. So now basically what we've got is basically we've got all this information that's landed in this kit environment. The kit environment's kind of running and it's basically displaying it all. And if you've got the kit application running locally, it's beautiful. You're seeing it all. But the next step is being able to take this and say, okay, well, we're not just in a local environment. We want to be able to send this across the web. So the up and coming, it's not publicly released yet, but it's coming soon, is basically the ability to basically take that kit application and stream the interactivity of that environment directly into a web page. So that allows you again, allows you to actually mash up if you want to create these mashups of information. So you could be bringing in Power BI data, you could be bringing in data from Tableau or anywhere else into this web page, and you can actually have this interactive environment whereby if you have selections in the web page, having the stage respond to it. When you have selections in the viewport, basically the viewports are sending information back to the web page. The web page is basically reacting and bringing in that analytical and operational data that you might want to be displaying as part of your solution. So it's really a coherent environment whereby you can create React or Angular apps or just straight JavaScript apps if you'd like, and kind of have this interactive viewport and talking interactively with the kit application in the background to provide a nice kind of end user experience with respect to your data and your visual representations. So it's pretty, it's pretty high level representation of what we're doing. Trying to keep it simple. We're open to basically any kind of data sources, any kind of application development from the endpoint to the endpoint. But what we've done is basically provide you with a functionally decomposed environment with respects to your skills and your actual code base. So you don't have to worry about the code bases running over each other. You can have different visual representations for the same sets of data. You can have multiple sets of data pointing to the same visual representations, and there's nothing kind of blocking you one from the other. So there's a clear separation of concerns, and that makes it very actionable because you can actually have people working in isolation on one part without actually impacting the work that somebody else might be doing in another part, and you can actually bring it together from a project management perspective nice and easily.
That's great. We actually have an interesting question here from Ordinary Alan. Believe it or not, my dinner mate last night, I'll put it up on the screen. Is the durable storage data encoded in USD or something like JSON and the kit app changes to USD?
Typically, what's going to happen is the USD APIs are used to write the data. The internal storage representation is proprietary inside of Omniverse. But the easiest way to get in there is basically to write the data using the USD APIs. So you'll be writing attributes or properties and fields. So it's really just tag value settings that'll end up in USD on the other side, even though the internal representation is not per se USD.
Great. And then another follow-up question here from somebody else. Can the headless connector handle real-time data in the OPC UA server?
Yes.
Easy answers. And so sorry about
And
covering your webcam there, Ganesh. Didn't mean to do that.
No, that was exactly the question.
Yeah.
That's a perfect question for Alex to dive right in. So that's exactly what we're going to cover in the next few minutes.
That's great. Okay.
Awesome. So I can take you through. So what I'm going to do now is I'm going to take you briefly through this. It does seem very slide weary, but there is I've got everything, all of the stuff you've seen today is actually also running on my machine live. So if I do drop off, actually, it'll probably be because my machine's my machine's fallen over running all the stuff.
Fingers crossed.
Yeah, fingers crossed it doesn't though. So basically, the architecture Richard's shown and Ganesh has spoken about is all based off of a sample, an Omniverse sample, an IoT sample that takes data from MQTT and enables you to, like at a very simple level, ingest it into USD. So what my team and the guys on the team that I work on, what we did was we took that sample and we've kind of applied it to some of the industrial IoT Azure products that we use, so like using IoT Azure IoT operations. And briefly, while I remember, before I go really in depth on the technology, uh, just a note about the size of our team. So someone asked about the size of the team, I think,
Yeah,
and
I,
how
th I
many
think
people there was.
one of the things we often hear is that, especially when because we have a lot of companies of all sizes watching a live stream, and it could seem very overwhelming. And wow, how many people would it take to do this? What size team do I need? People who really want
Yeah.
to leverage digital twin tech. But as I know, and I think you're about to share, it doesn't have to be that big actually.
No.
So
No, not at all. So the team that we had, well, I mean, Microsoft is very big, but the team that we had specifically wasn't particularly large. I mean, it, maybe at most the amount of people working on it any one time was maybe 5 people, but to be honest, there was like 3 or 4 of us doing it. So, and we've got knowledge of the whole end to end, right? So if you take away the IoT stuff and like all of the onboarding of the data, basically if you've got USD and Omniverse and you've got an MQTT broker with some form of JSON on it, that's all you need. And one person could do that, right? As long as you understand JSON and USD. So, it wasn't that many people.
it's great.
Um, yeah, it was pretty good. So, I'll take you through this architecture now. So,
So,
the architecture here. Yeah,
so
sorry, Ganesh.
yeah, Alex, I just want to add that that's awesome that a small team can get started very quickly. It just requires a little bit of knowledge on 3D and USD and Omniverse, a little bit of knowledge on IoT, and a little bit of knowledge on actually how to kind of stitch those two things together. It could be one person who has all that knowledge, as Alex said, or it could be 2 people having that different skill sets and that can actually tag team together to get started. So the barrier of entry to do all of this is not significant, as long as you have some basic understandings of both sides of the world, the industrial automation world and the 3D and the Omniverse and USD.
I think that's very reassuring for all the companies out there. If you're just joining us midway through the live stream, we are chatting with folks from NVIDIA and Microsoft, and we're demonstrating how to build physics-based operational digital twins with OpenUSD. Alex, you were just about to proceed.
Oh yes, so we'll dive in. So this diagram here is like a really high level architecture diagram showing how we took the IoT sample from NVIDIA, the Omniverse IoT sample, and we applied it to Microsoft's new Azure IoT operations stack, which is primarily targeted at industrial in the industrial IoT IT space. And in this example, we're using a robot arm to stream some data into Omniverse. Now, how we're doing that is we're connecting we've put an OPC server on top of a robot arm, which has 6 joints. We've used the Azure IoT product to do that, and like all the stuff we show you here is like all available publicly, so you can try and use it yourself. We've then taken an Arc-enabled Kubernetes cluster which has IoT operations on it. We've deployed a thing called an IoT MQTT bridge, which basically takes your MQTT on the edge, and makes it available in the cloud via a thing called an event grid. So it surfaces onto that event grid. You've got event grid topics on there. And then we've got our headless connector, which is deployed as containerized application deployed on an Azure app service, but you could probably use a container app, or you could deploy it on the edge if you wanted. It doesn't have to be in the cloud because it's containerized. And that uses the MQTT client, and that uses the USD APIs to update a USD stage. So what we're going to do next is go into, so I'm going to talk about the actual, very quickly talk about the process of it. If you go to the next slide, Richard, and then we'll dive into each of the little bits and see how we get to the end result, which was that video you saw at the start, and I'll hopefully be able to show you it running live. So we're listening to MQTT on event grids. There's a hierarchy, a set of topics that are hierarchical. We then use the universal namespace style of topics to generate a hierarchy in the USD. And we'll have a look at that as well. We then look at the JSON payloads of the messages that we're receiving. In our example that we did, we're trying to rely on open standards, so we're relying on the OPC UA delta frames and OPC UA keyframes. I think we're doing event frames as well, but we don't really use them at the moment in this example. And then we're writing that, so the green dots here are where we're talking to USD, and we're writing stuff to USD via a live session. So if we go to the next slide, Richard. So how do we build up our prim hierarchy? So what we're currently doing is, based off of the OPC data, we're actually, rather than writing directly to the robot arm with the with the connector, we're actually creating this separate hierarchy of data. It's almost like a data layer. So it's separating it from the 3D model, so you don't step on people who are doing 3D modeling. It's just going into this separate data layer, which is in its own little live session. So the actual USD, the stage that's maybe composed of lots of different USDs, overall isn't affected. So you're not going to, it's non-destructive. You're not going to destroy your asset hierarchy and accidentally inject loads of IoT data into your pristine USD hierarchy. So what we can see on the right here is what we call transforms and prims. So there's primitives and transforms. That's how you organize a USD. I'm sure people on this call know what that is because it's an Omniverse call about USD. So what we do is we go and look at the top. When messages come in, we look at the topic that the message came in on. If we take a brief step back, we're actually listening to the MQTT messages on a wildcard topic. You don't have to, but we're listening to them on a wildcard topic. And you'll see in this hierarchy, we've got IoT, which is the IoT connector. Then we've got OPC Delta, which is your data. We're kind of using it as a data source. And then we've got the asset hierarchy, kind of an asset hierarchy. I'm running this as a simulated robot arm. So I've got IoT operations data sim, but that is basically a reflection of the topic hierarchy. And then the leaf nodes, so my robot is called sim, and then my leaf nodes are actually the OPC tags. So if we go to the next slide, you'll see this is just how we extract the data. So there's an example payload there, the JSON payload of the OPC UA delta. And you'll see in there, there are other properties at the top, but we're not using them at the moment. So what we're actually doing is we're using the dataset writer name, which IoT operations, or when you create an asset in IoT operations, which is a collection of OPC nodes or tags, it's given a dataset writer name that currently maps to the kind of the notional ID of that machine. So in this instance, it's sim, but it could be robot arm 1, it could be conveyor 1, it could be palletizer 1. So we've got a delta frame here. This is actually a slightly unusual delta frame because it's got all of the changes for all of the joints in it. However, you may have one or more tag in there because it's a delta, it's the changes, it's not a keyframe. What we're doing is we create a leaf node for each of these keys underneath the payload. And then if we go to the next section, so we're still building the hierarchy. If we go to the next section here.
Oh, sorry.
That's right.
Next slide. Okay.
No, this one's good.
Right.
I think this was okay. Yep. So then once we've passed those, we then go through and we take those key value pairs of source, timestamp, and value. This is a very simple implementation. And what we do is to those leaf nodes, we then create raw USD properties. And you'll see in this code here, we're looping through the payload properties, we're extracting the key values, we're doing some string tidy up on the property names, creating a semantic label, and then making sure that the prim exists as a scope. And we're just updating the key value pair. Now we're not doing any checks to see if it's changed or not, because when you see, if we look at the code, we'll actually see that we're specifically, this bit of code is specifically for OPC UA Delta frame, so we're expecting it to be we're just relying on it to be a change, and this probably could be way more efficient, right? Because every time we're getting a property at the moment, we're checking to see if it exists, then adding the scope. And you could do all sorts of things around caching, but this was more of a kind of an MVE example that we've used. And if you're at HMI actually and came to the Microsoft stand, this was behind the scenes running to move the robot arms. So if we go to the next slide, we'll then see how. So that, and you can see those updating. So then we can see how the robot arm moves. So we've got an animated GIF here of the robot arm moving. So the actual moves of the robot arm, this is where we've separated the concerns slightly. So the headless connector is simply doing that data hierarchy that we had. To move the robot arm, we're actually using we're using physics. So what we're doing is we have a custom kit application, which is called Operational Digital Twin Viewer in this example, and it's got a little bit of config in it. And what it does is it listens to the USD notice objects changed event. Taking a brief step back, so the connector creates this live session. It's updating those things in its own little session, which I forgot to mention. This goes and finds that it's configured to find that specific session. It joins it and then listens to the notice changed events. And then using an underlying URDF configuration in this instance for the robot arm, it then goes and applies the physics angular position and the drive physics target position. And then behind the scenes, the Omniverse, the physics engine at Omniverse, I think it's called PhysX, I might be wrong, then applies the actual rotations and the moves to get it into the right place. We're not doing any collision or rigid body stuff, we're just doing the moves. But if you wanted, you probably could do condition and collision and rigid body stuff. And that's when, if it's all right, Richard, we could pause for questions, but I might also steal the screen to show it running, if that's all right.
I think that would be wonderful. Whenever you're ready, you can start sharing, and I will swap over. Keep the questions in. This is super informative. Thank you again for tuning in, everybody. If this kind of content is helpful to you, please don't forget to like and subscribe, as we do this every week on Wednesday. And see, we have hundreds of people watching now live, so feel free to keep posting your questions and comments in the chat, and we will try to get to them as quick as we can. I think, Alex, I'm seeing your amazing environment.
There we go. So for a tiny bit of background, the part of Microsoft I work in, we have a tiny miniature factory facility in Houston. We have all sorts of robot arms. Some of them might be familiar to people who've been to Hanover Messe or to various conferences we're at. And what I've done is I've taken a copy and I'm running my own desktop, a simulation on my desktop of the robot arm, and then I'm streaming to the cloud and bringing it back down. So here's the robot arm moving in real time. You can see my computer doesn't like sharing my screen and moving the robot arm at the same time because I'm getting 10 frames per second. It's normally better. So that's the end result. However, just to prove that it is running in the cloud, if we go and look here, we've got an Azure App Service, and you'll see that it has a funny name on it as well. I mean, that's because I provisioned it using bicep scripts. So I can just script this to spin it up, but we'll see. I've put the log level to trace, so we can see all of the OPC UA Delta frame messages coming through from the OPC server. You can see they're all different and getting applied relatively quickly. I mean, the source timestamp here, it's not that far behind. And then, so the other piece I was going to show you is the configuration in IoT operations. So IoT operations allows you to create what we call assets. So I have a robot on a grabber on my machine, and this robot is configured as a simulator, streaming data into that event grid that we were talking about, which this is then subscribing to, which is then updating the USD, which is another thing. We can see our live session here, and you can see we've got our Omniverse, Omniverse nucleus.azure nucleus, so that's our Microsoft Omniverse instance that we happen to have. And the other thing to note is this is all using, it actually is signing in with proper authentication tokens and security. So like the connector signs in with its own user with specific permissions on the correct USDs based on the security, the role-based access you can have on the different pieces of USDs or in your USD storage.
Very, we have a good question here. I'm going to put it on the screen. And if it's too deep to go into right now, we could provide some resources, which we will a little later. But can you explain detail about how the IoT data of robot access is transformed into the movement simulation of the USD model?
I can show you the code that's doing it. I probably can't go massively in depth. Like I can show you the piece that's updating the robot pose. So I did in that PowerPoint there was the code, but it's also here. So I mean, we're in this instance, we are relying on the NVIDIA physics engine to update the rotational position and the that combined with the URDF model, which is the model that defines how the robot can move and all of the metadata about the robot arm. That's kind of how we're doing it from the headless connector end. I don't know if Richard has anything else to add about the more technical details about how the Omniverse engine actually applies those changes.
No, actually, it's kind of just baked into the physics engine, which makes the transformations really easy. You could do deterministic transformations, but then you'd need kind of like to manage your own loop in order to move it on the frames, which is all handled by the physics engine. So you're kind of getting it for free.
Yeah, and that's something to note. Actually, we did originally, like the first part of this, we were manually moving. We did have something that was basically doing like linear interpolation, saying, "Well, I got an IoT message that says the thing is this robot arm has moved to here." So it was like we were actually moving it without using physics, animating it and rotating it and doing all sorts of like transformational stuff around like the Unity equivalent of lerping and moving the robot arms. But this is when we found out so the other thing to note about our team is we're learning how to use Omniverse as well. So when we found out about this, we were like, well, it's a no-brainer. It's way easier. We don't have to write the code. So
that's great. What a great example. We got some great questions coming in from the community. Here's one. I'll put it on the screen. Did you face any problems in deploying simulation to reality or reality to simulation? I don't know if we need to have more context on that.
I think the question might be, Alex, about actually doing like offline programming and programming the robot itself in Omniverse, and then figuring out whether that set of programs and the actions is like the final blueprint, and then push it from the sim to real and then real to sim kind of thing. So I think that's what the question is about. This specific example is about the operational digital twin. It was not about the sim to real use case. So that's a good question, and we may have to cover that as a separate session, if that's okay, Edmar.
That sounds great, actually. And for everyone watching, we're going to be sharing some resources towards the end of the live stream. So get your pen and paper ready. But we'll put them in the chat, and we'll share them on the screen. I already posted a GitHub earlier samples. Fantastic. Let me see. And this might be also somewhat along the same lines, but let me see. You have problems with fine-tuning stiffness and dumping.
Well, I mean, so that's an interesting one. That's more when you are going. So we have had issues with that in the past, going from like what Ganesh was talking about, like offline programming, building a robot program, and then applying it to a real robot. You do come across those issues, and it really is. Sometimes it is just a case of fine tuning. I mean, I like to call it robot ops, right? You build your robot program, you test it, it seems okay in your simulated environment, you deploy it to if in the development world, it'd be like dev, test, and prod, right? You have a test piece of hardware, you deploy it to that test piece of hardware, and then you fine tune. You have to fine tune within your engineering tolerances there, and then apply it back to the program, and you can keep going through that iteration. And I guess that's really part of what a digital twin is, right? If you go in the realms of software engineering outside of like the physical, it's the physical equivalent, right? When you write code, you have your dev, test, and prod. You have CI/CD. You in your development pipelines, you have a simulated environment. You might do smoke testing. That simulated environment, you could say, is a twin of your real environment. And we're just taking those. Part of what we're doing is taking those software engineering paradigms and applying them to the physical world, and we happen to call those digital twins. Which I don't know if I answered that question, but
I think you did. I think that's great. Another question here. From an architecture standpoint, will the IoT data go into OVC?
So when we are talking about OVC, again, just to qualify, we're talking about, I think the better way of looking at it rather than OVC or OVE, I think it's the same question. It's about, if we go back to the slide share again, Richard, I think that will probably set the context. So the Omniverse slide, I think it was the first slide of yours, Richard. And I think you can speak to that better. But the way to think about it is, yeah, it's that one. Is the way to think about it is on the right side, you have storage and you have nucleus. So the data does go into some kind of a storage system. And from there, you're hooking it up and bringing it back into the custom kit applications and rendering that data in USD. But Richard, why don't you actually answer that question?
Yeah, it's basically it's currently it's a nucleus. It could be a local nucleus if you're running a local host. It could be an OVC, or it could be an enterprise nucleus that's doing that. And moving forward with the cloud APIs, there'll be a more flexible model for being able to store the changes that'll be coming in off the headless connector.
yeah, I think the other thing to note is as well, like when you've got like this headless connector streaming data into your operational twin representation in USD, you probably will be sending that data somewhere else as well, to other cloud services for your like time series
Correct.
historians and your business analytics, Power BIs, your real time operations dashboards, which would be like in Fabric, or if you use open source stuff on the edge, you might be using Grafana. This is just one path that data you will send that to other places more likely than not.
Great point.
I have a question regarding action graphs. This is from the NVIDIA team. I wonder if someone approached using action graphs to connect to IoT.
Yeah, in the samples, there's a sample of actually using Action Graph to be able to do codeless manipulation of the IoT data.
Amazing.
So you're not bound to being writing Python code. You can just basically trigger an event on data change, so any kind of attribute or prim change, and then take whatever actions you need to manipulate the stage.
Yeah, I think it'll be super helpful, Richard, if you go to the resource slide. And everything that we described here in this live session is basically a collection of the kit app template that is on our GitHub, in the NVIDIA Omniverse GitHub repo, the IoT samples repo, yeah, that one. And then there are resources that Alex has shared around the Azure IoT operations, as well as the how to configure an MQTT bridge. So, with all the four of these, everything that we have discussed for the last 45 minutes, one can quickly get started and get going with the similar kind of use case and examples.
Great. And Amelia will be posting those links in the chat for everybody, so you do not have to scribble those down on a piece of paper really quick. We'll post those. Big thanks also to Amelia, who's been helping with the chat throughout the live stream. Again, amazing questions coming in from the community on this topic. Really great to have everybody here. Let me see. Eric has a good question. How does a proprietary storage piece scale from an architectural perspective?
Well, the storage model is a scalable model, so it's really dependent on if you're using OPC, it's got the whatever the cloud resources are available to you are, and if you're using an OVE environment, then basically it's whatever resources be allocated inside the enterprise. Locally, again, you're kind of limited to whatever your machine is if you're running a local instance of Nucleus for doing this, but there's no real top end to it. I mean, there's stages that are very, much bigger than any GPU can handle, and the storage environment can easily absorb that.
The sky's the limit. That's awesome.
Yeah.
All right, we have a question on machine learning here. Does Omniverse have an ML engine that can provide contextual synthetic data, digital twin for predicting fringe scenarios? That's a good question. Who wants to tackle that thorny one?
I think it's about training using synthetic data, right? That's a whole separate product and a team that's addressing that. We'll probably have to deal that separately, Edmar. Not something that Richard and I can actually specifically speak to.
Okay, so be on the lookout for upcoming SDG live stream
Correct.
where we tackle into
Correct.
synthetic data. And we actually have a couple we've done in the past. So if you're watching, feel free to check out our YouTube channel and just do a search for synthetic data generation. And you'll
Correct.
see some resources there. Okay, let me see. Here's a question. Have you thought about using Sparkplug specification for MQTT?
That's a good one. Alex, do you want to talk about that? That's a Sparkplug. I think it's the Sparkplug B. It's a different kind of a specification. It kind of is using the MQTT as a transport, but then again packaging it in a different format. So in my view, Alex, I think it's just a payload. It's just a different kind of payload, and that could be parsed and hooked up, similar to what we are doing here. But what are your thoughts?
Yeah, I mean, you could use that. I mean, you could use Sparkplug B and package and unpackage it. I think the reason we used OPC in this instance was just to show kind of, our team uses OPC for things, so we just wanted to show that we can build a standard thing and we can just plug and play it across lots of OPC things. But you could certainly use Sparkplug B specifications easily.
Yeah, and Sparkplug B is kind of a newer way, and it's still not yet prevalent and ubiquitous as much as OPC UA. OPC UA is much more adopted widely. So that's one of the reasons why having OPC UA as the data format for this example is what we use. So yeah, but again, as Richard was saying, bring any data, any format, any protocol, it doesn't matter. You can still be building your operational digital twins. It's fully agnostic.
Yep.
Great. I know. So I missed a question a little earlier. Let me circle back to this one from Pavel also. Will we put send command back to robot from Omniverse? So again, this is be a more of a.
So the headless connector by default is a bidirectional environment. So basically, what happens is it creates a session layer. So you've got the session layer living inside of Kit application. You're basically writing to the same layer in the headless connector. And then what happens is that anything you write back into that session layer in the Kit instance will automatically flow back to the headless connector. So it's really just a matter of you taking the code that Alex did earlier, right? That event notification, that USD change notification happened. And if you add that back into your headless connector, you'll be pulling back the changes that were made in the Kit instance. And you can do whatever you need with it at that point.
Yeah, and then but then on top of that, you can do all of the stuff to do with cloud to ground or whatever you want, because then you're onto the MQTT bus. And if you're using something like IoT operations, it's bidirectional. You can send data down and initiate commands, do cloud to ground pattern, which is part of the IoT operation stuff. It's in preview at the moment, so it's all good.
This is great. Big thanks to Amelia for she did finish pasting all those resources into the comments. So feel free to click away and learn and grab everything you can there. And you could always follow up with the team on this live stream in the live stream channel on our Omniverse Discord server. Again, that address is discord.gg/NVIDIA Omniverse. I can't believe the time has just flown by. We're almost at the hour mark. It's just fantastic information. I also super excited to see um, this presentation, really inspiring and getting a lot of people's interest up on how to leverage this. So thank you so much to Alex coming over from Microsoft and Richard and Ganesh. Also, a big thanks to James McKenna from the NVIDIA team, who really also helped pull a lot of this information together for us. And it's just been fantastic. If you have any last minute questions, feel free to post them in. Otherwise, we'll head into some closing comments and any additional advice that our panelists have for those who are inspired now to get started. So I'll start with Alex. So Alex, you've made a compelling case here, and including the information that really took a very small team of just a few people to get a lot of this work done. So what advice do you have? Any parting words for everybody?
Well, so my parting advice maybe would be like, I mean, the team that I'm on has picked up and learned Omniverse stuff and learned how to use Omniverse Cloud over the past 18 months, and we built something like this, and this is only really scratching the surface, and especially in the area of robotics, using Omniverse in the area of robotics, especially around things like offline simulation of robot arms and synthetic data production. It's an awesome world to get into, and especially when you then pair it with the real world stuff, so creating real twins, IoT operations, and streaming real data and creating operational twins. It's really good.
Fantastic. That's great. Richard and Ganesh, any parting
Yeah,
words from you?
yeah. It's the IoT samples. It goes to one of the questions that's out there with respect to Hello World. Really starts with something simple. I mean, I am by no means a robotics expert or physics expert. Really just starts with a series of CSV data and then kind of brings you up from CSV to MQTT to various things. So Hello World starts with CSV, pumping CSV, and it's just basically manipulating a cube in the stage. So again, you don't need to be a USD expert, you don't need to be an MQTT or IoT expert, but it kind of gets you the pieces that you need together. Bring those pieces together, get something visually appealing and visually interactive with respect to the data. So it's about keeping it simple.
Yeah, in my previous role as the product guy for the Omniverse IoTs, Richard and I exactly took that approach of how do we create like an Hello World IoT sample example. So the GitHub public repo that we have exactly addresses what just Richard said. So you actually have kind of created a end-to-end self-contained project that actually creates that synthetic MQTT IoT data as a CSV file that's driving the transformation of a conveyor belt with a box on that conveyor belt. So it's probably one of the best places to get started. And I think building these operational digital twins is becoming more and more real and more required from the digital twin use cases that we have been exposed to. So yeah, this is exciting, Edmar, and thank you for bringing us all together and hosting this. This was super exciting.
It's been an honor, really fantastic. I'm so glad that you all able to come, and great presentation, great information all throughout. And thanks again to everybody watching for all the great questions. If you tuned in late, again, this is available right away on our YouTube channel. We were joined by Microsoft developer Alex Hayward and NVIDIA developers Richard and Ganesh, diving into how to build physics-based operational digital twins with OpenUSD. Touched on a lot of things, including Kit and Azure. So feel free to rewind and watch and check out the resources that are in the links. We'll also update the description and timestamps shortly. This has been fantastic. Thank you all for joining us. Until next week, we have a nice surprise in for next week as well, on a somewhat related topic, a nice project we're going to show off from a program of NJIT. So look out for the ad event calendar. Amelia will post a link for the ad event calendar so people can check the upcoming live streams there. But until then, we'll see you on Discord and on the forums and out there in the world on LinkedIn and everywhere else. And thanks a lot for joining us, everybody.
Thank you. Thank you, Alex. Thank you, Richard. Take care.
Thank you, everybody.